to wonder, way back in the mountain, so ancient and wide.
Tonight, we're going to, you've seen the animation here, maybe, that was playing earlier that showed the meteor coming in from space and crashing into the mountains that were here before Yellow Creek was here, Yellow Creek Valley. And tonight, Dr. Stephen Greb from the Kentucky Geological Survey will tell us about the meteor and its and the crater and what it did to the strata, to the valley. And he is a professor as well as a member of the Geological Survey, and he teaches. He told me a couple of classes there at UK. I'm assuming that. Being a teacher, he can project so that all of us older folks can hear. So,
can you hear me in the back?
Hear you. Yeah. So with that, take it away.
Well, thank you very much. I really appreciate y'all for coming out tonight and for Bob for inviting me. It's a pleasure to be down here. I love coming to this part of the country. So, as he said, I'm Steve Greb. I'm with the University of Kentucky, and the Kentucky Geological Survey is a research institute of UK. Go Cats. Right? All right. And we're in charge of collecting data on the geologic resources in the state, researching that data, and making that data available to the public. I work in the energy section, which is in charge of collecting data on oil, gas, and coal, and we also do some of the environmental issues surrounding all of them. What I'm going to tell you about today is geology of the area. I'm going to kind of key in on several different parts of the local geology, and then I'm going to open it up for questions at the end. And at the end, you can ask me about local geology or any kind of earth science question. I'm also pretty informal. I'm used to teaching classes with kids that are much less interested than you are in what I'm saying. Or if you know anything, please feel free to. Pretty informal. I don't have the high-tech movie thing, but that's... All right, so what I'm going to do is start with just a kind of general geology of the state. Now, I start out my geology talks with a general background of kind of why Kentucky is the way it is from a geologic perspective. And as a geologist, I'm very interested in what the bedrock is like and how the bedrock influences topography. And I step through these. So we're going to start out with the general geology, just to get everybody on the same page, what was happening in the state. I'm going to zoom into the local geology, talk a little bit about coals and the coal-bearing rocks that surround the hills around here. And then we'll talk about Pine Mountain and this block of rock that you're on. All right? And it's a block of rock that's moved in the past. So we're going to talk about that, this big block of the Earth's crust moving to form Pine Mountain. And then we'll talk about, I'll briefly mention Cumberland Gap because it's important to the local area here. And then we'll spend the last half talking about the impact. Okay? Just gives you a heads up on what I'm going to do. So one thing is, whenever we look at rocks and we're looking at landforms, topography, we're looking at streams, that's the culmination of a really long history. And it has a lot to do with the geology and how the rocks are at the surface. Because some rocks are easily weathered, and other rocks are much more resistant to weathering. Some rocks hold water real well, so you can keep creeks at the surface. You go into southeastern Kentucky or central Kentucky, all the streams go under. You're familiar with these kind of maps, topographic maps. All right? These are done by the U.S. Geological Survey, and they're at a scale it's called 1 to 24,000. That translates to about 7 by 10 miles. okay? Most of the US has these. Kentucky, we have the entire state covered by these maps, all right? What Kentucky has that most other states don't is we took the same scale map and we did the geology on top of the topography at this same scale. There's only one other state in the nation that has that, and it's Rhode Island. And let's be real, Rhode Island doesn't count. Rhode Island's like 2 Kentucky counties, right? So we like to say we're the only one. But this was a program that the USGS did, the United States Geological Survey did in cooperation with Kentucky back in the 60s and 70s. And Kentucky was pretty forward looking, and that the USGS was looking for a partner and wanted to try this out to see if it would work. They originally planned to do it for the whole country, and Kentucky stepped up and said, yeah, we'll do that. Use us as this experimental ground. Our entire state now is mapped. All right? It's a huge benefit to industries, to environmental groups, all sorts of stuff. You understand what the rock layers are beneath you. I work sometimes in other states that don't have these, and I have to spend a couple of weeks just figuring out where I am to start out with, right? About 10 years ago, the USGS decided to get this program going again, and they decided, though, that let's make this more technological, so let's make it digital. And let's have everybody make their new maps digitally so you can get them on the web and just download stuff. And our state geologist went there and said, yeah, you can do that for all the states. I understand why all the states would want this, but you know, we're already mapped this way. It's a much shorter step for us to have the entire state done digitally. And we got a bunch of money to do that. And so because we stepped up, we have the only state that's done at this scale digitally. A mouse click away, you can zoom in. We have the air photos, the LiDAR, zoom in on your house and find out what the geology is right underneath your house. All for free. Good benefit for the state.
Do we just go to your website?
Just go to your website. And I'll show people how to do that at the end of the talk. All right. I'm going to skip down and concentrate on the geology right around here, which is Pennsylvanian age rocks. And at the bottom of the Pennsylvanian age rocks are these big, thick sandstones. And these big, thick sandstones make what's called the Cumberland Escarpment, running from about London, Corbin, northeast on that side of the basin. And then here, because of the faulting, they come back to the surface again. And they're underground between there. And so Cumberland Falls, Pound Gap, Pinnacles, Pine Run, that's all these big, thick Pennsylvania age sandstones. So they're a good scenic tourism boom to the state. Here's the White Cliffs on the other side. Right. All of those sandstones were from big rivers that once were here. And the pebbles that you see in those, we can trace some of those back up to like New York and Pennsylvania and maybe even farther north. So they tell us that a long time ago there were these huge rivers that flowed through. Mississippi scale rivers once flowing through Kentucky. And for a long period of time, those rivers flowed through here and they went south towards where Alabama and Georgia are today. And that's where these big cliffs are from. All right? Above those and in between those, we have some of our coal beds. All right? And we are blessed with a lot of coal beds. All right? Now, did you know that Kentucky is the official state mineral? That coal is the official state mineral of Kentucky. How many knew that? All right, here's one of the funny things about that. Did you know that coal really isn't a mineral? Right? Coal is a rock. Right? So in school, we teach students that coal is a sedimentary rock. Many years ago, at the state legislature, a school group went to their local representative and said, you know, we don't have a state mineral, and we should, and we'd like to make coal. Of course, the Coal Association was all behind that. A lot of people that like coal were all behind that. They brought it to a vote. We got a call like the day before it came up for a vote, and one of our geologists went down to the State House and they said, hey, we have this motion to make coal the official state mineral, and our geologist kind of got up in front of everybody and said, well, I hate to bring this up, but scientifically it's a rock, not a mineral. And then one of the representatives raised his hand and said, we tax it as a mineral. 100% approval. The next year, we made agate the state rock. Agate is a mineral variety of quartz. So Kentucky now has the only state mineral that's really a rock and the only state rock that's really a mineral. I like to show that just shows the need for more science education. Coal beds obviously are a big part of eastern Pennsylvania. So younger than the rock strata we have preserved, we have a series of faults that cut that rock strata. And so the timing, we know the timing of the faults because we can see what rocks it offsets. So the rocks had to be there flat before the fault was. Right? And so we can figure out the timing of some of these. So if we look at Pine Mountain, this would be Pineville here. You're back here. There's a series of faults. There's one big fault and it kind of splinters at the edge of Pine Mountain. And that's pushing rocks up and over the rocks in front of it. So if you drive towards Pineville and you're looking on the left side, and you're also watching traffic in front of you, you'll see all the rocks are tilted underneath all the dead kudzu. If you go to Pound Gap, you can actually see the rocks. The kudzu hasn't gotten there yet. Right, but you can see this tilting of the rock layers in front of Pine Mountain. Right, and when you get just on the other side of that, all the rocks are flat. Right, and the rocks that are at the surface here are more than 1,000 feet down on this side. So you can see that it's pushed up and over. You can see this from space, so this is just a Google Earth image. Here's Middlesboro, here's Pine Mountain, and the Pine Mountain Fault. It actually sticks out from space. Here's Pine Mountain. And you can see there's a whole series of these all the way back into Southwest Virginia. And at Pine Mountain, you're at the western edge of a whole bunch of forces that were pushing rocks that way. It's kind of the last gasp of the Appalachian Mountain forming interval. That's why. And you can see it just gets more intense as you head back towards Virginia. This is now tilted, this is north. So Pine Mountain's the leading edge, and you go back here to Clinchport and the Clinchport Fault, Kingston Fault, defines a block of the Earth's crust that has actually been pushed up and over another block of the Earth's crust. That block of Earth's crust is 2 miles thick, and it's been pushed 13 miles. All right? So imagine how much force that took. The thrust itself, this break, the red line here, is in Devonian shales. And a shale is a laminated rock. It's very fine grained, and it's in terms of potential to move or change, it's greasy. So when these forces got applied to this big stack of rock, you had this package of this black shale in there that's kind of greasy, and essentially that's what tore. And the upper part ripped up and went over another part. And if you go just through the tunnel into Virginia to where the iron furnace is, and there's the railroad tracks next to that old iron furnace, and you make sure there's no train coming, and you look on either side, you'll see all this beat up, torn, and swirled black shales. And that's where one of these faults is coming back up to the surface there. You'd see the same thing in Pineville, except now the city of Pineville sits over part of it and the kudzu covers everything else. Aside from this big block, then we also have a whole series of little faults that kind of cut across it. And these are tears in this big block. So you imagine you have this thing 2 miles thick, 25 miles long. You don't move that as one big, even unit the whole way. There's parts that move a little bit faster, move a little bit slower, so it tears several places. And there's a fault that goes right along Route 25 here that's one of those tears, called the Rocky Face Fault. And you can see that in several outcrops north of town and just a little bit east of town. And to move that big block took a lot of intense pressure. And what scientists think is this is a time when continents were colliding together, and North America actually collided with what is now Africa. So you had 2 continents that collided, and that's what made the Appalachians form. It didn't form overnight, it took millions and millions of years, but but each collision just pushed another block up and over the next one. And we know it's Africa. There's all sorts of different ways, but one of the fun things is if you go down, who's going down to Florida? If you go deep underground in Florida, the rocks deep underground in Florida are the same rocks that you find in Morocco. And they aren't anything like the rocks you find in Alabama or Kentucky or Tennessee. It's actually a piece of Africa that got stuck to our continent. Okay? That's why it's a little weird to you. So we'll move now. Cumberland Gap come up. This is Pine Mountains, the one side of this block. Then there's kind of a little wrinkle. That's where Cumberland Mountain is. And the gap, that is why, one of the reasons this city is here, one of the reasons we had settling in Kentucky, that's where this rocky face fault intersects another fault in this wrinkle kind of in this big block. And because you have a fault, you have a lot of fracturing. Because you have a lot of fracturing, water could get into the ground. That means more weathering and erosion. And so the mountain weathered away there. And there's a big hole, a gap. Every one of the gaps that is in Pine Mountain, if you go all the way up to 25 or 30 miles of Pine Mountain, is where a fault crosses through. So it had a really strong impact on the topography, which had a huge impact on our social history. All right. So here's Middlesboro. This is Pine Mountain. This is the Rocky Face Fault. There's a series of faults back here behind Cumberland Gap. This is a map of Middlesboro that shows several kind of rings of faults and this brown color in between. What I'm going to do is step through how Middlesboro was mapped and different pieces of evidence that came along that suggested there was a meteorite impact and how geologists came to that conclusion. And then I'm going to show what that data means. Okay, so we can reconstruct what happened. All right. So whenever geologists see rings of faults, there's several different ways rings of faults can occur. The two most common are from volcanoes and then impacts. All right? And on Earth, volcanoes used to be thought of as much more common than impacts. No evidence of any igneous rocks or volcanoes or anything deep underground in Middlesboro at the surface of Middlesboro, so you can, through negative evidence, kind of cross that off. You can't say that 100%, there's no way ever that somewhere deep down there wasn't something that never made it to the surface, but right now there's absolutely no evidence of it. So that kind of leaves impacts as the likely category. So the first thing that happened in 1964, Ken England, who was a geologist with the USGS, mapped this area. So we have these maps that I showed you, and he was in charge of mapping the Middlesboro area. So he went out and he went up to the hillsides and he saw these faults. This is behind the Lee's recipe, where a coal bed is almost at a 45-degree angle. There's a fault right behind that. If you go up to where the Holiday Inn now, you can see a whole series of faults behind the Holiday Inn. And he went in and started mapping those. And he had old mine maps, so he knew where mines intersected a fault because the coal bed stops at the fault. So he had a whole series of these things and he starts mapping them. And he ends up with these rings, and a pretty complex series of rings. And I knew somebody that worked with Ken. I asked them once, how sure were you of the rings? Because as a geologist, you want to make faults straight lines, and you like them to be parallel. If I was in the field doing this, I would have gone back to my notes afterwards, and I would have said, oh, I took a wrong measurement somewhere. There's no way that it ends up as a circle. There's no way. And he said at first they questioned themselves, and then they went back and did it over and over again. They kept coming up with this circle of faults. All right? So we have this, that's the first thing. All right. The second thing is when you come inside the ring of faults, where most of the city of Middlesboro is, if it's not covered by the alluvium from the creek and you see actual bedrock, it's not normal rock. It's what we call a breccia. It's broken up rock that's in a finer grain matrix. And this is not the breccia from here. I didn't have a good picture of the breccia from here. It's the breccia from somewhere else. But it's angular fragments, small little fragments of rocks in a finer grained matrix of rock. They're all mixed up. That's what we call a breccia. It's kind of like a conglomerate, which is what the pebbles are up in the cliffs at the pinnacles and you see up at the top of Pine Mountain, except in conglomerates, the pebbles are all rounded. Okay? But this is just fragments all beat up. So that's a very weird rock type. It's very weird to have it over big areas and to be pretty thick. And in water wells and things that were drilled around here, as deep as you make it, that breccia is there. All right, so we know that breccia was big, and it's confined to inside the circles of faults. Next thing is in the center of town, you have a little hill. It's right on the other side of the golf course. That hill has older rocks that have come up to the surface through the breccia and younger rocks. And if you look at the elevation of the top of that hill and the elevation of the stuff around the hillsides that's not faulted, it's way younger rock. All right, which is weird. You usually don't see just a hill of younger rock popping up to the surface. All right, so that was another kind of weird thing happening in this area. Then somebody found shatter cones, and this kind of changed or focused people in on the impact. This is a shatter cone, and I think this is one of the ones that was originally found. Shatter cones look like markings in rock, like you were stacking ice cream cones or cups. They have this kind of cone and cone and cone stacking, real narrow, and they start crisscrossing each other. And it's a very weird looking kind of rock, and it's not something that you find a lot of. Keith Milam, who was a graduate student, found this piece over by the golf course, really nice piece of these shatter cones. The only places they're known on Earth are nuclear bomb test sites and the Arizona meteor crater. They take intense pressure to form. So finding that here in Middlesboro took any kind of the question that people might have had of is it an impact or not. We can safely say there probably wasn't a nuclear explosion here a long time ago. Well, people would know about that. Definitely slides. You get all sorts of really complex faulting in a ring around where whatever the thing was that hit. And then inside what you're left with is really broken up rock. It's broken up from the force of the impact, which had a directional force like that. It's broken up then because there was then all that got rebounded back up, and then it collapsed again. So there's 2 or 3 different directions of force that took this huge pile of rock and just broke it up into little bits. All right, and that's what forms the breccia. All right. Now, what you're left with then at Middlesboro is kind of a basin or a topographic lobe with a hill in the middle, and then the hills, the normal hills, the undeformed hills all around the side, and a ring of faults with breccia inside. Now somebody asked me when I came in here if we found pieces of the meteorite. All right, so the answer is no, because what you see here is not the crater. What you see here is the rocks that were all broken up way beneath the crater. The crater was there was probably up to a mile or more of rock above your heads back in Pennsylvania. And it's been eroding ever since then. So any crater, the crater that existed has long since eroded away. Any of the meteor impact dust that fell back to Earth, long since eroded away. What we see here in the hills around us is the erosional remnants way beneath the original crater. And when people are identifying impact sites and potential impact sites, there's actually a ranking. So for a meteorite impact site that's a 1, and I don't remember the exact numbers, let's say that it's 100% sure that it's a meteorite impact site, that means somebody saw the meteor and watched it hit. All right? And immediately after that kind of drops to a 2, which is we found pieces of the meteorite and a big hole in the ground. And then after that comes hole in the ground with a lot of broken up rocks, no pieces of the meteorite, but things that show super high pressure. After that comes holes in the ground, rings of faults, nothing that's super high pressure. So we are in the likely, and I think very likely meteorite impact here, but it doesn't fit the 100% for sure, nobody saw it. But I'll tell you that no geologist doubts that this was an impact site. All right? So, the next question is, when did it occur? All right? So, that's a harder one to determine because all we can say is the youngest rocks at the surface here are broken up, and they're from the lower Pennsylvanian age. And we're missing this huge amount of time in between. And we know that the sediment from the river that covers it covers the fault. So it's older than the river, it's younger than the rocks that are at the surface. There would be other areas of the country you might be able to go sideways and find an ash deposit, and you could link it up. Here we can't. What we can say is that we have this big block of the Earth's crust that Middlesboro sits in and the crater sits in. It's still a circle. That block of Earth moved 13 miles and was being pulled and stretched in all sorts of different directions. It's unlikely it would have remained a circle if it formed before Pine Mountain moved. It's also, with all this broken rock, it's probably one of the places it would have torn a lot easier through. So most geologists think it happens after Pine Mountain. So that's after Appalachian Mountain forming, which is how you get the age that is probably latest Pennsylvanian or Permian. And I think in the video they said 200 to 300. Okay? So that's, we know it's at least then. We don't have any idea in the 200 million years after that. We can't get it any closer than that. Now maybe someday in the future somebody will figure out an ingenious way to date things better. But right now, we don't have a better idea than that. Now, you asked about the dinosaur extinction meteor. That's in the Yucatan Peninsula. If you ever go to Cancun or Cozumel, you go about, I don't know, 50 or 75 miles north and you were at ground zero. Right? It's also underground. It's way bigger than this. It's 150 miles or 200 miles wide. It's a huge hole in the ground. That event, same processes, but just orders of magnitude more. It's been estimated that if you took all of the nuclear arsenals in the world, put all those bombs at one spot, and blew them up, you'd still have to go 10,000 times more than that to get the force of that impact. It created tidal waves that, there's rocks from the Gulf of Mexico in tidal wave deposits in central United States. So you had a tidal wave that was probably on the order of 800 feet high, emanating out in every direction. For example, the real bad one that hit Thailand a couple of years ago, I think was 16 feet high, 15 feet high. 800 feet, that's higher than the arch in St. Louis. It's a huge lot of water. And then all that rock getting blown into space, the theory is that it created total darkness, all the plants died. Once all the plants died, the plant eaters died, and the plant eaters died, most of the meteors died. And the only things that survived the dinosaur extinction event are things that are less than about 15 pounds. So pretty small animals, things like rodents, lizards, salamanders, they do fine. Right? Possums, ancestors of possums, cockroaches. Cockroaches have been around since Pennsylvania times. They've survived three mass extinctions. But as gross as it is to say, they're about the perfectly evolved animal. And they don't look any different than humans. But that was a huge event. This is significant.
So there's no evidence that these low-grade iron ore deposits around Middlesboro were from the meteor, right?
No, the low-grade iron deposits from around Middlesboro, as best as we can determine, there's a unit on the Virginia side. It's in the Silurian rocks. The name's not coming to my head, but I could look that up for you. It's a limestone that has iron cement in it. It's the same, or very similar limestone to what is down in Alabama that was some of the old, really big iron works in historic times. And it's that cement that's in the rock that is what was the iron ore. And unfortunately, it's pretty low concentrations of iron, and it's pretty much restricted to a small interval of that bed, and that bed only comes to the surface over a relatively small area. So all of those things, I'll get to that, didn't do well for the history of this area. So I'm was kind of scared to talk about, really briefly here, the history of Middlesboro with the historical people. This is blatantly copied out of your site and what I could find on Wikipedia, but obviously Alexander Arthur gets credited for trying to make this the Pittsburgh of the South. I'm sure some of the people here might say they're trying to make Pittsburgh the Middlesboro of the North. All right, and what he wanted to do was take the coal to make coke, and coke is the easiest way to think about it is you take the coal and you make it kind of into something that's like charcoal, and it gets put in with steel to pull the oxygen out of the ore that has the iron in it, to leave just the iron. But you need a certain kind of coal to make a good coke. That's what we call a met coal. There is some of it around here, but not every coal that makes a good coke to make a good met coal. He thought there was a lot of iron in the hills. There is iron, and it's the kind of iron that got used historically to make iron and steel, but not an awful lot of it. And then he hoped, obviously, to make this a big steel producing town, and unfortunately less iron in the hills than he thought. He had the unfortunate circumstance, from what I understand, of being at a time when the industry was changing, and he was still trying to use some old technology when some really new technology was being used much more efficiently.
Best in the process.
Yeah. And then the other thing is, if he was thinking he was going to get coal in Middlesboro, the hills have plenty of coal, but the top area in the center here doesn't because of the impact. It's all broken up rock. So he had a couple of strikes going against him, and obviously it didn't work out. But what I like to say is 130 years later, the geology and the earth resources here are still really important to the town. And that there's the tourism and the history here is one of the big features of this town.
Way back in the heat